when we saw the game is evaluate what was realistic physically with the game pieces and the field, as well as inside of the rules in terms of physical limitations, what kind of size restrictions especially, was very important to finding out what was possible as well as at least what could be done with the game pieces. Our strategy relied on being versatile, but at the same time not being too complex, because naturally in a Robot in 3 Days project, being really complex is going to make everything very tight in terms of timelines, as well as any kind of problems that show up aren't going to be able to be fixed inside of that short time, which is why we wanted to go with a simple yet versatile solution. And all of our strategy relied around both being able to pick up the garbage bins and the totes. The pool noodles weren't as especially important to us because by the time that you have garbage bins on top of totes, you've made enough points that pool noodles aren't going to matter too much. We also didn't care about the landfill very much, mostly because of the fact that there's 30 totes behind the player stations, allowing you to make at least 6 stacks of 5, which is a lot of stacks.
For the T.E.S.L.A design, what we have is this mechanism that we see right over here. When we move the bottom of the arm, it goes and moves along these 2 guide rails along the path, so it lifts up linearly. For the El Toro design, what we have over here is we have, if we look at this from a top view, this is a roller and a roller. So it goes and sucks in, a tote or bin when the robot comes on contact.
One of the prototypes we built in order to pick up the crates was called the flappy arm, and the flappy arm was basically one stationary arm fixed right here and another arm that was driven by a motor to be able to turn, just basically rotate it like that. So the advantage of this was that it could pick up the crates because it would be just the right size of the crates. It could also open up and pick up the bin, and this would allow you to have multiple angles of attack. The prototype for the elevator was just 2 rods going up, and we had the T-slots which it was sliding up through. We tied the middle slot with a gearbox that had a chain wrapped around it, so the chain spun the axle and the axle pulled up the base, and it just slid on the T-slots.
When the decision was made to have 2 robots, we needed to be able to have a control system that could work for both. So I created a modular electronics board that could easily be switched between both robots through the removal of about 8 motor controller screws. With the smaller board, it made it easier to just mount anywhere on the robot where there was free space. The final consideration was being able just to mount our batteries as low as possible on the robot to be able to have a low center of gravity to prevent tipping.
As you can see, when they're going, as we raise these, the hooks grab onto the bin, and the tusks underneath help support the bin and also change their angle as this is raised. When it's raised this high, you can see that the bins do not fall off. Once it's raised, we can drive up to another bin and lower it down and drive away. And you have a stacked tote box. When the robot is in this position, it can put the bin on top of the tote boxes by lowering the horns down and driving back as it does that.
So this is our second model that we have, the forklift design. For the base, starting at the base here, we have an almost standard kit of parts chassis, small modifications. The front is taken off to allow for the mechanism to be integrated into the chassis. We also have a piece right here welded on for structural support. We used steel for this piece because it needs to be a strong brace. We don't have any issues with the weight as of right now, so we decided to go with steel there. Back here, we have a single PG motor driving a winch. This aircraft cable goes up and to lift the mechanism. We considered using 2 motors. It is very difficult to coordinate 2 motors, we found, unless they are being driven on a single shaft, which was also difficult to build. So The reason for that is unless they lift evenly, this mechanism will bind as it lifts if one side lifts faster than another. One motor will have the torque, lifts this up to a single pulley mounted up here in the middle on the steel, so we're sure that this steel will not bend. We've tested it a few times. So from this being spread out to balance the weight, it mounts on the very bottom or as low as we can on this mechanism. In this position, we try to keep this as vertical as possible to maximize our force. We just have some bracketing here to attach this to what we call a bearing box here. So in this box, what we have is a bearing running through this axle and this axle where the weight will be. And then this is just pure steel rod that fixes the spacing in this direction and that direction. So these two are steel rods. These two have bearings in them. When this goes up and down, because there's weight on this here, these two bearings will be in contact most of the time. This can raise up and down using these L channels here. These L channels can accommodate the width of the bin with a tolerance of about 1 inch. They can accommodate these bins with a tolerance of about 3 inches. On the front, we have this grinded off to a curve so it can pick up the bin. The way this picks up the bin is by driving it against the wall, and it can go underneath the bin and raise it. This right now is raised slightly off the floor, but this can go all the way down to floor level. This bar going across is to support the bin from tilting one way or another in case we're slightly off, and allows for support.
Coming into this, I thought building a robot in 3 days was a very daunting task. Many of us, when we came here, we didn't actually have the skills beforehand to go and create the robot. And we were able to go and create 2 robots within 3 days. Not just 1 robot, 2 robots within 3 days. That is a huge accomplishment that I can't even fathom. So any rookie team has the potential to do this. Yeah, good luck.